Soil salinity and acidity are two major soil health issues facing North Dakota producers throughout the state. With more acres affected each year by salinity and acidity, the remediation and management of saline and sodic soils cannot be stressed enough. Even though closely related and having many characteristics in common, soil salinity and acidity are two different problems which should be dealt with differently. The alleviation of these problems requires slightly different management practices. The main cause for both excessive soluble salts and sodium in North Dakota soils is the parent material of the soils within the state and the underlying sodium-rich shale that is present in the bedrock below the soil sediments. The main carrier for bringing these close to soil surface is the high water table level and capillary rise of soil water.
Saline soils will have excessive soluble salts, which limit the ability of plant roots to absorb soil water, even under wet soil conditions, causing drought-like symptoms. These salts, however, keep the soil structure in good physical condition, creating conditions conducive for good soil water infiltration and drainage. Also, since soluble salts are mobile in the soil water, they can be leached out of the plant root zone if we lower down the water table level. In contrast to saline soils, sodic soils have excessive levels of sodium ions adsorbed at the cation exchange sites. Soil sodicity is not an excessive salt problem, but it is an excessive sodium issue. Excessive sodium greatly weakens the forces that hold clay particles together to form soil aggregates and leads to the plugging of soil pores or the degradation of soil structure. That process is called soil dispersion. Once that happens, it severely impedes soil drainage, making it even more difficult and expensive to manage than soil salinity. Remediation of sodic soils will require application of soil amendments like gypsum, elemental sulfur, or sulfuric acid, apart from lowering the water table level. Unlike soil water, salts or sodium don't evaporate and can only be leached downward into these soils with the help of rainfall water. That'll require lowering the water table level, which will facilitate the leaching of salts under good drainage and rainfall conditions, and application of soil amendments in case of excessive sodium issue.